Well, I understand that the idea are a little bit of abstract. Let's use an example to highlight some of the important issues. Okay. One example I usually use to illustrate this problem is the GPS data. Okay. As the more and more devices, mobile devices, capture GPS signals as we travel, as we move around, there has been a huge amount of GPS data collected. Okay. For example, if you think about people moving in the city, people actually moving the city around the roadways, and over time, you're going to capture a huge amount of traces of GPS. This kind of data has both a spatial and temporal characteristics. Okay, so the measurement can be easily represented as what they call a space-time cube. But this cube is like a mess. Okay? How can we make sense of it? Is always a challenge. Well, one way to make sense of this data is to start with a very broad idea that we would imagine this data could tell us more about where the places more significant, because we can imagine that places more significant probably are more stopped by people. So based on that idea, we will start with the traces of GPS signal, which corresponds to the data store that we talk about. And we can actually start with the first step as to extract the stops. Okay, so based on the time and that the GPS transition from location to another, we can tell where they stops, and collecting those stops into a small shoebox we can talk about is a kind of pieces of evidence. Okay? And then we can use the second step, we can use clustering methods to count the frequency of stops. Okay, and that becomes some evidence for human to make judgment. Higher frequencies of stops probably indicating more significant. And if we have that data, we can be ready to present this data to human and for them to see the judgment that they can pick up where are the most frequent or least frequent stops, and they can make sense in the right spatial and temporal context. We can also ask, can we use GPS data to tell us what are the typical routes of movement between different places? Okay, this is the question that kind of add on to the earlier question. The way we can address this question, again, will follow this sense-making loop model. Then we start with GPS data, and we can query and extract the sequences of positions that have transitions, okay, and connect them from one stop to another. Okay, this kind of sequences becomes pieces that can be integrated, synthesized into evidence pool. The second step, basically, we can cluster those evidence to find the similarities and the frequencies of those routes. And those can be aggregated by their spatial relationship and computationally summarized into frequencies. Such data can be readily presented to human in the right geographical context. That will be some basis, okay, starting point for human to understand the movement between significant places.